Right, so here we have the internal amp board from the little Rookit 5 doobie-dobby speaker thingy-mabobby, these things, little monitor speakers. And yeah, a few people have come across this, I'm not the first. So yeah, try and do this all through the teeny tiny little screen on the camera. So this black gunk they put all over the board, I'm not sure what the word is. I don't think it's hydroscopic, I don't know, hydrophobic, something that doesn't like, well anyway, it's irrelevant. As you can see by like this white crustiness on here, autofocus is going to go crazy. I should probably turn that off, but hey ho. Anyway, you can see it's basically water. It's sort of water gets under it and it sucks it in and it holds it in, and then parts of the board under all the bits that have the black gunk on them start corroding and causing issues. Luckily enough, this one, it's mates, he's had them a few years, probably about 5 years I think. I seem to think he got them back 2014. And he's been using them just really like hooked up to the telly and stuff, just for watching films. And he'd started noticing I was having a few issues turning on and stuff. And I said, well, whether that's got anything to do with it, I know these things suffer from the black gunk of death. And is evident on here, it has definitely been holding water on it. This doesn't look too bad because I took this apart probably a month or so back, and it has been, we've had some nice heat this summer in England. It's been nice. I think just after I took these apart, it ended up like peaking at 38 degrees or something, and we've had weeks and weeks of heat, so the water that was under these has actually been driven out mostly. Let's have a little dig under, shall we? Let's get the massively oversized screwdriver out, and you see the very poor adhesion to the board because water has gotten in and gotten under. It doesn't look too bad there. I don't know what state the other one's in, but yeah, the only real damage massively evident on this one without digging this all off is this bit just down here. You see there's some lovely white corroded circuit board links there, and it's around this resistor. You probably might not be able to pick it up. Yeah, you can just see like see just there by the screwdriver that resistor leg started to corrode through. It's gone all blue. So yeah, it's just I'm sure if I start examining a bit more I'll probably find a few more issues, but I can't really see a lot because I've got the camera between me and it. Better for you, not so good for me. So yeah, anyway, it's just literally a case of, like I've just done there, just pull it off, clean it, replace any corroded bits, and put it back together again. So yeah, I can't do it for the camera because, you know, like I said, camera in the way, but yeah, should be fun, shouldn't be an overly difficult fix. See if the other one's any worse. One of them might be really bad, who knows, but yeah, that was all just another little Rookit black gunk of death video, because you know there's not quite enough of them on YouTube, or pardon me, heartburn, on YouTube already. But yeah, anyway, and if you see this, Logan, finally got round to working on your speakers, mate. I know it's been a while, but you know, it's been hot and I couldn't be bothered. So anyway, that'll do. So that's the black shite removed off everywhere it needs to be removed. So a few casualties. This transistor, if we'll focus in on it, now if you can see the green all between the legs, that had like a blob of, so that sat just here somewhere on the board, right there. Sat just there. I had a big blob of black stuff actually on it and under it, and yeah, there was actually quite a lot of water still under the black stuff. I thought it dried out, but once I started scraping away at it, it was actually quite wet underneath. So yeah, that I think, you know, I've not I've not even attempted to reverse engineer it. I don't have the schematic, but it does look like this is part of an audio chain. But seeing where it sits, it may be part of the standby circuit, and yeah, that's definitely been short, and that's a lot of it removed. It was as I've took it off, a lot of that green crud's come off. You can see like it's down to the copper inside. Yeah, this leg had almost completely rotted through, and as soon as I tried to remove it, it just snapped. So that's gone. Small resistor, there's a 1K5, sits just here. That had rotted through. Some rot on legs here. All the wire that connects to the board is, again, you're going to struggle to make it out. Bad lighting and bad focus. Yeah, all the wiring's gone like grey and crispy and blue, where every bit of wire's had a blob of it on top, so it's held water onto that. And yeah, apart from a few damp spots here and there around this resistor and stuff, it's okay. So yeah, that's this side of the board has suffered a lot more damage, and this side, who knows why. But yeah, so that's this one. So I've got to get a I'm going to need my eye loop to read that one. Yeah, this is like a tiny little quarter-watt resistor buried in there. This teeny tiny, don't fall out my hand. That one, it's like a quarter-watt, if not quarter-watt, an 1/8 watt. So yeah, it's a 1K5. And this little transistor is an unreadable, even with my eye loop, I cannot read it. Hopefully I'll be able to get part number off the other one for that. If not, I'm going to have to do a little bit of reverse engineering and see. There we go. It's just getting in light right. 2SD66 something A. 667A. So 2SD667A. I'm going to probably say this one down here is probably highly likely to be the... Should we see if we can get that on the camera? It's unlikely. There's the camera. There's the lens. Oh no, that's a totally different one. Focus, come on, just for a second there I had you. That's a shame. I actually had that for a second there. That is a... There's a 2SB647. So 667, 647s. So anyway, yeah, minor damage, nothing nothing massively untoward with it. So it's not through plated, which makes life easier. It's dual layer board, but it isn't through plated, so unsoldering components is a lot easier. So that's not bad. On the surface, 2 dead components caught in time. I did find after spending ages scraping this, if you get a squirt of like just some cheap electrical contact cleaner, which is just basically IPA, isopropyl alcohol, in a aerosol can, I believe. I'm pretty sure if you look on here somewhere it says contain propan-2-ol, which is isopropanol, I do believe. Yeah, just some isopropyl alcohol. You spray that on, give it a few seconds, and it just meh, piece of piss. So next one's going to be an awful lot easier than this one, but you live and learn. That's what you do. First attempt at one, next attempt at one, going to get on a lot better. So yeah, I'm sure I can get a 1K5 in there if I just turn it at a funny angle, and I should imagine I've got a transistor that I can substitute into there. Something I've got in my box will fit. But yeah, the old black gunk of death. They tried well. They wanted to make sure everything was going to last and be vibration free. So they slathered it in black gunk, but they didn't realise that the black gunk would hold moisture against the board and end up destroying all the components they were trying to protect with it. It couldn't have known, whoever designed it. I'm going to say he. It could have been a woman, but you generally find 90% of engineers are men. So I'm going to say there's like a 9 in 10 chance it was a bloke who designed it. But yeah, simple solution to a simple problem, and see what the next one brings. Right, so I've pulled the other one apart today. I got the gunk cleaned off this one. I've not ordered the bits yet because I thought I'll probably need to order the same bits for both modules, and it turns out no. So this one, that transistor was that one there, but on this board, but you can see whoever put the gunk on here didn't put any around that transistor, and whether the camera will focus on or not, come on, come on. Yeah. So yeah, right, you can see the capacitor legs there. Well, the goo is actually only on the capacitors, it's not causing an issue there, it's on the legs. On the other board, whoever was responsible for shoving all the goo on shoved it absolutely under everything, and that's where it started causing issues. So on this board you can see, give me some more light on the job because the camera's going to struggle to see that. Pull that wire out of the way. So if you look to the very right of the board, above where this cap says 5 on it, just where my finger's pointing, well, the camera picture, you can see it's all green and crusty. That's components completely corroded through. This resistor here, it's rotted from the legs to the outside, all the casing's flaking apart on it. It's not too bad, this one. There's another one, you can see a nice blue resistor in the middle there, and the lead, where the right hand black lead is, to the left of that. You can see crusty resistor, you can see crust up on, there's some wire links just where my finger's pointing. They're all crusty at the top, some resistors above them, wires to the side. So this one's seems to have gotten a little bit moister, a few more corroded wires and links, but there's less black gunk. I'm going to say the resistor buried under this gunk here. Fantastic framing there, Liam. Where's my zoom gone? So that 1K fire resistor on the other board was under here. Yeah, you can just make out the leg of it. Again, fantastic frame. You can just make out the leg of it there. So how well that's going to have survived, who can say? Same again, soak it in IPA and see how it gets on. I've not actually put these two boards side by side to see if they're identical. They are. They appear to be. Notice on this one there's a lot of goo, these two big caps in the middle. There's a lot of goo right up and into them, so I'm going to probably have to pull them out, because I should say water's ended up getting under them and corroding them out. So as it stands, the board I've cleaned needs that transistor replacing. It needs 1K5 resistor, and it needs a capacitor. There's a capacitor just up there which had corroded through as well. But everything else on this board seems okay. After cleaning it off, the wire links and stuff are okay. The resistors on the side here, not too bad. Bit crusty, but still measuring okay. Lead's still intact. So yeah, which is odd. It's odd that the placing of the black gunk was it's not like, you know, they've had a production line where one bloke's been tasked with putting black blobs in exactly the same areas. It seems to have been just randomly done at will of whoever had the board in front of them deciding where they want some black goo, some on the wires, and I imagine the mandate was, if you see anything that sticks up and looks like it might vibrate undone, shove some black goo on it. But yeah, there doesn't seem to be a complete consistency of where the black goo is between the two boards, but same problem. Black goo, water on boards, water corrodes electronics, corroded electronics don't work very well. So couple more hours of cleaning, well, probably about an hour. It's not too bad a job, it's just fiddly. You can't just go in and start prying it, Will, because you're going to end up prying all bits of stuff out. So, joys of repair work. And on the sides of these bloody heat sinks, where they touch the back of the case. So, let me get one of the cases, right? It's completely frigging pointless. So, oh, hey, there goes the camera. So, hang on. Right, so here's the back of the case. That sits on the back of the speaker. And you can see there's a sill pad in there for some reason. And then this heatsink sits up against it, and they'd like put goo on it to make it, well, the heatsink works by convection. It cannot conduct through that very edge any useful amount of heat really into this back plate, and this black back plate is just a smooth sheet. Alright, it's got a fair surface area, but the conduction point compared to its surface area, it is minimal. Now, and this one gets me right, the white goo you put on the back of semiconductors to when you mount them onto heat sinks and stuff is not a particularly good conductor of heat. And I know that sounds a weird thing to say, it's called heatsink compound, but most people use it the wrong way. It does not make a better thermal bond by putting a big splodge of it on. Its sole intention is, although this looks smooth, if you was to look at this under a high power microscope, it would look all pitted and cratered, there'd be mountains. I think they say something like, if you was to get a snooker ball, which is a very smooth object, and enlarge it to the size of the Earth, it would be rougher. In other words, the mountains and the valleys and stuff on it would be bigger and deeper than what we have on Earth. So, you know, this is a rough surface, it looks smooth, but on a microscopic level it's very rough. And same with the back of the transistor, so you end up with little micro pockets where there's not very good adhesion, there's no physical contact between the back of the transistor and the surface you're mounting it to. So you put the tiniest, thinnest smear of heatsink compound on, you like wipe it off with something like a back of a credit card, old credit card. So it's just like a white smear, like basically sort of what you can see left on here almost after I've cleaned it off. And when you clamp the two surfaces together, those all teeny little microscopic gaps have something in between them, and although the heatsink compound is not a particularly good transferer of heat, it is more firmly conductive than the air that would sit in those microscopic gaps, so it allows better cooling. But when you've got a big lump, like, you know, it stops localized hotspots and stuff for you. Remember, those transistor dies are tiny, so you don't want a localized hotspot here, because you end up with all sorts of problems. You'll get like instantaneous secondary breakdown or thermal runaway. It's like a localized hotspot in the transistor, and it'll just blow. So you need to try and keep that whole die cool. Now, thinking that somehow you're going to get better thermal adhesion by putting heatsink compound on here to here is questionable at best. But the one that's really baffling me is a friggin' sill pad. So silicon pads are like the worst thermal conductors you can use for heat sinks on the back of transistors. You want Captain Take or mica isolators, something like that. You get like it's like a white ceramic-y stuff. It's like a beryllium oxide or something. They're good. Sill pads, terrible, cheap, easy to fit. But a sill pad, now you use it because you want to insulate the back of the transistor from your heatsink electrically. But you'll notice this heatsink has screw holes here that go through there. It's electrically connected via those screws to this case. If you want to optimize the thermal contact between this case and this heatsink, I don't think putting a sill pad on there is the best way of doing it. All I can think is they're trying to achieve is hoping that minor differences in the surface of the heatsink and the case will be soaked up by the sill pad. But you're still going to end up with the problem. It's going to be putting high pressure on the areas where it touched and very low pressures on the area where it didn't touch, and ultimately the sill pad again doesn't conduct heat as well as just bare metal on metal. And I think personally it's it's a foolish thing to think it's going to help. All I can see is it doing is hindering the process. You'd be far better with imperfect contact with areas where it doesn't quite meet on here and here, and trying to force it to meet by basically the areas where it does meet, holding them apart with the sill pad and allowing a very low pressure point where the sill pad's in the bigger gaps, so there is at least contacting, but it's all the way along, it's now a barrier. But ultimately, finally, really, if you want to use this backplate as a heatsink, then you'd need to mount these electronics on here straight to it. Trying to get it to just conduct through this small surface area here, this is convecting most of its heat into the air and warming up this enclosure inside, and that warm air is going to be transferring some heat through this backplate. And there's going to be some localized heating through this, but very little. If you wanted this to really conduct heat into here, then it needed to be a solid block laid across it with these mounted on it. But like I say, you'd be better off mounting these straight to the back. But let's say, you know, technically that was hard to do. You're just going to be better off with just a solid metal block here with these mounted to the metal block, and then the circuit board coming up and off of that. Yeah, the more you look into it, it's really weird because these speakers, they've like taken time to seal all the back, and you know, it's a very nice shielded transformer. It's a banded shielded transformer. Yeah, and then they go and do stupid things like shove black goo over everything that holds moisture in, or somehow hope that a small surface area of just a few square centimetres is going to somehow conduct all this heat away from this heat sink and into this back plate. If you really wanted heat to conduct away through this back plate, what you'd have is a heat sink external to it. Many examples of fine pieces of engineering with external heat sinks, and then it wouldn't have to be as big as this, because if this is having to lose heat inside a sealed enclosure, then you're going to do an awful lot better with having a vertically mounted heat sink on the back. I should probably change the camera angle, but I can't be bothered. You'd do far better to have a vertically mounted heatsink on the back of this thing, sort of that way on, and like I said, the device is onto it. So yeah, I'm not sure. There's some engineering is a compromise, but I feel they've made a few flaws here. I've got a question. I mean, I didn't make, you know, it's easy to pick faults in someone else's design. You know, well, if you're so good, do it yourself, mate. But yeah, I kind of feel there's some room for improvement on these. I don't know what the later models are like, but you know, that's just a bizarre setup with that heatsink indeed. And I'm going to guess the high thermal cycling of the air inside the unit is what's led to this water ingress into it. So it warms up, the air warms up, its ability to hold moisture increases, so any moisture in the outside air as it exchanges, it's going to get held inside the enclosure in the warm air in there. And then when you turn the speaker off, as the inside air in there cools down, you're going to reach the point where the vapour pressure of the water is less than the vapour pressure of the air, or it's hard to explain evaporation. It works on like a vapour pressure thing, so you don't have to boil water to get it to evaporate. As long as the vapour pressure of the water is high enough to overcome the forces of the air, yeah, it's a hard thing to explain. Thunderfoot does a good video of it on his YouTube as to how water evaporates and stuff. But basically, at some point, at some temperature, as temperature of the air decreases, the amount of water it can hold also decreases, so the water redeposits itself. And for some reason it seems to like depositing itself. Well, however, it might deposit itself on the whole board, and it might just be that when it gets under this black stuff it gets trapped in there, or who can say. But anyway, I'm going to say that's probably what's led to this. If it had had an external heatsink and didn't undergo such high thermal cycling, I'm going to say it probably wouldn't have suffered this fate. And what probably would have helped as well is a small tub of like silica gel, like tightly held in just like a tub, like pepper pot style, with little holes in it. You know, if it was held tight enough it wouldn't rattle or anything. But you know, I'm sure they've probably addressed it on later models anyway. I'm just waffling on and on instead of actually just, you know, I'm just putting off getting the bloody screwdriver out and cheap IPA out and scraping this crap off, just waffling on and on. So anyway, right, let's go cracking on with some fun time scraping fun. So a quick splodge later, and this one, what have I got? So this resistor here, completely corroded through. What is that? Brown, grey, orange, brown, grey. 8. Was that grey or a green? 18K, I think. 1/8 orange. I think grey's 8. Something K anyway. 18K, something like that. This resistor here is pretty corroded, about 1K5, so that's going to have to come out. This one here, red, that's 2K2. That one down there, it's all, I don't think the camera will pick it up, but it's all corroded through. And you can see there's sort of brown at the top of it. It's actually all the case on it's like all corroded. You can see on those terminals, that's even after a good scraping, there's still a bit of green on the board, but it's down to the metal underneath the shiny coating, whatever the internal metal's made out of. This one isn't as bad as the other one is. We'll see. If you do this, if you find yourself with a set of these doing this, I've noticed it's only where the black crap is really piled in high there seems to be a problem. It must, like I say, must attract water and then it traps it. Where it's just thin, it doesn't seem to have caused any issues. Where it's like just a teeniest little slaver of it over a component lead or whatever, it's barely a mark. So when you're cleaning it off, I'm going to say don't worry about getting the board looking absolutely spotless without a trace of it on. So, you know, it's not going to cause an issue like on this wire on the insulation up here. There's a little smither of it still left. And like on the board, you can see there's like little traces of the black. But it's so thin there, it's just like a staining almost. It's not going to be an issue. It's something to do with where it's thick. It holds moisture. Where it's thin, doesn't seem to be too much of an issue. But yeah, that's the black crap cleaned off. Do I have to? Oh, that's right. Now I've got to pull the little preamp board out as well, because I had to do it on the other one. There is a small amount on the preamp board, which brings the next question: where on earth is the small preamp board? That's a good question. Oh no, it's still in there. It's on both of them still. Duh. That's right. Yeah, I just had to scrape a bit off. Round here, there's like a resistor and stuff. It's nothing major. It's not on majority of the board. It's just on these edge connectors. So a big splooge of it goes on this resistor. And the lead was a little corroded, but nothing major. Scraped it off. Like I said, because it's not in between the components holding water, and there's a bit on these capacitors here as well, but again that's up in the air. It's not on the components where it's going to cause an issue. It's down at circuit board level. It seems to be really be an issue where it gets under something, so you've got something above it and then it traps water in between the two surfaces, whereas where it just sits on something, it doesn't seem to be an issue. It's you know, you've got like all these various different shapes, curves, so if you get it on the component legs, it gets under the component and above it, and water sunlight gets in between it and the component legs, and it's then trapped in there. That would seem to be the issue with it. So yeah, I've only got a few components to get, nothing major, so hopefully it should all be good. He was saying the issue with these was one of them was taking a while to turn on. I'm going to say it was that transistor on the other one. But yeah, they're very simple. Look, both amplifiers are just based on a little chip amp. The chip amp being a No way near enough light. TDA, is that a 2052 or something? Ooh, what is that? Yeah, TDA 2052 and another TDA 2052. So little 1, 2, 3, 4, 5, 7-pin TO220 packaged little chip amps. Yeah, and a couple of op amps, some basic filter circuits. Yeah, nothing fancy at all. Yeah, just a, I never got that term, studio monitor. I've always had in my head a studio monitor should be like a speaker that perfectly reproduces the entire spectral range with minimal phase shift and minimal node reinforcement or cancellation, you know, full spectral, absolute necessity. And how a set of teeny little speakers with little, what are they, like 4-inch drivers, maybe 5-inch drivers, how they can produce the whole frequency range in a tiny little case and with just a few watts of power amplifier. Yeah, I don't know. I'm doubtful, but it seems to be a thing, doesn't it? That studio monitor. Yeah, I don't know. You tell me. Anyway, that's all for now. Thanks for watching, and otherwise, catch you next time.